complex is a really exciting branch of mathematics. What happens when you get something like x squared plus 1 equal to 0? How can you find the solutions to this? Well, we know that there are no real solutions, but there are complex or imaginary solutions. So what do you do whenever you want to take the square root of a negative number? What you do is you break it up into the square root of negative 1 times a, and then take the square root of negative 1 and multiply by the square root of a. Now, we're going to need to define a new term, and that's I. And I is defined to be the square root of negative 1. So, if I want to take the square root of negative 5, this would be the square root of negative 1 times the square root of 5, which is I times the square root of 5. And in general, we put the I in front of a radical. Now, let's look at this. What happens when I square I? When I square I, that's the square root of negative 1 squared. So the square and the square root are our inverses. And so I'm just left with negative 1. What is I cubed? Well, this is I, which is the square root of negative 1, times the square root of negative 1, times the square root of negative 1, which is the square root of negative 1 squared times the square root of negative 1. Now, the square root of negative 1 squared is negative 1, and the square root of negative 1 is just I. Now, what is I to the 4th? Let's see. It's the square root of negative 1 times the square root of negative 1 times the square root of negative 1 times the square root of negative 1. So when I multiply these two together, this is the square root of negative 1 squared times the square root of negative 1 squared. So the square root of negative 1 squared is negative 1. This is negative 1. So this is plus 1. So you see how exciting you can explain some pretty weird things using these complexes. You can start with just what I is and talk about I squared. Now the one here that you really need to remember is I and I squared. We're not really going to do the cubes and the fourths. I just really like them. Now the complex plane consists of both the real numbers and the imaginary numbers. And the imaginary numbers have pure imaginary numbers and then mixed imaginary numbers. So any number can be written as a complex number, a plus bi, where this is the real part and here is your imaginary part. Now, if a is 0, then you have a purely imaginary number. If b is 0, you have a real number. We graph things in the complex plane. In the complex plane, we take the x-axis, and we call that the real axis. We take the y-axis, and we call that the imaginary axis. The absolute value of a complex number is the distance that point is from the origin. So if I have the point 3 minus 2i, that means I'm going to come over 3 in the real plane, and I'm going to go down 2 in the imaginary, on the imaginary axis. So what is that distance there? Well, it's going to be the square root of 3 squared plus 2 squared, which is the square root of 9 plus 4, or the square root of 13. So how would I write the square root of 18 using I? Well, I'm going to break it down into its primes. So this is negative 1 times 3 squared times 2, because 18 is 9 times 2. 9 is 3 squared times 2. So this is the square root of negative 1 times the square root of 3 squared times the square root of 2. So this is I. The square root of 3 squared is 3, and I'm going to leave the square root of 2. Now, how would I graph these numbers? 6i. Well, 6i is really 0 plus 6i. So I'm going to go over 0, but then up 6. So this point right here is 6i. What about minus 5 plus 3i? Well, minus 5 plus 3i, I'm going to go to the left 5 and then up 3. So this point right here is minus 5 plus 3i. Now, what's the absolute value of each number? Well, for 6i, that's pretty straightforward that it's 6, but I'll do it anyway. It's the square root of 0 squared plus 6 squared, which is the square root of 36, which is 6. The absolute value of minus 5 plus 3i is the square root of minus 5 squared plus 3 squared. So this is the square root of 25 plus 9, which is the square root of 34.